Close your eyes and imagine leaving Earth behind, rising slowly through the atmosphere, past the clouds, beyond the blue sky, and out into the darkness of space. The familiar world fades away below you, and you find yourself floating among the stars, surrounded by points of light scattered across an infinite canvas of black. This is where our journey begins, not among the planets or the nearby stars, but much further out, in the deep spaces between star systems where some of the most beautiful and peaceful places in the universe exist. These are the nebulae, vast clouds of gas and dust that drift through the galaxy like cosmic dreams, glowing softly with colors that seem almost too beautiful to be real. A nebula is not a single thing, but a family of phenomena, a collection of different types of clouds that exist in space, each with its own character and personality. The word nebula comes from Latin and means mist or cloud, and that's exactly what these objects are: cosmic clouds floating through the vacuum of space, so large that it would take light years to cross them, yet so tenuous that if you could gather up all the matter in a nebula the size of Earth's orbit around the sun, it might not weigh as much as a small mountain. They're almost nothing, yet they're among the most visually stunning objects in the universe, glowing with soft colors, creating shapes that remind us of familiar things, even though they exist on scales we can barely comprehend. When you look at images of nebulae, you're seeing something that exists on a scale that's hard to truly grasp. These aren't small clouds like the ones that float through Earth's atmosphere. A single nebula might be dozens or hundreds of light years across, meaning that if you could somehow travel at the speed of light, it would take you decades or centuries just to cross from one side to the other. Within that vast volume, the gas and dust that makes up the nebula is spread so thinly that by Earth standards, it would be considered a better vacuum than anything we can create in laboratories. Yet there's so much space, so much volume, that even this incredibly thin material adds up to masses that can equal thousands or even millions of times the mass of our sun. The beauty of nebulae lies not just in their size, but in their colors and shapes. Some glow with rich reds and deep crimsons, the signature of hydrogen gas being energized by nearby stars. Others shine in blues and greens, colors created by different elements and different processes. Some are dark, not glowing at all, but visible only because they block the light from stars behind them, creating shadows against the brightness of the Milky Way. Each nebula is unique, shaped by the stars around it, by the motion of gas through space, by shock waves from distant explosions, and by the subtle influence of magnetic fields that thread through the galaxy. Tonight, as you prepare to drift off to sleep, we're going to explore these cosmic clouds together. We'll visit different types of nebulae, each with its own character and story. We'll float through glowing gas lit by the fierce light of young stars, drift past dark clouds that hide their secrets in shadow, and witness the beautiful aftermath of stellar death, where dying stars create cosmic art from their final breaths. There's no rush on this journey, no schedule to keep, no destination we must reach. We're simply wandering through these peaceful places, taking our time, letting the beauty and tranquility of these cosmic clouds wash over us like gentle waves. The universe is vast beyond imagination, and most of it is empty space, but scattered throughout that emptiness are these islands of gas and dust, these nebulae that mark the places where stars are born, where they die, and where the material of the cosmos is constantly being recycled and transformed. They're transitional places, regions where matter is between states, no longer part of stars but not yet formed into new ones, existing in a kind of cosmic pause between more dramatic phases. This makes them inherently peaceful. These are places where things are happening, but happening slowly, unfolding over millions of years rather than days or seconds, following processes so gradual that watching them would be like watching paint dry, except the paint is gas clouds light years across, and the canvas is the galaxy itself. As we begin our exploration, let yourself relax completely. There's no need to understand the science behind what we're seeing, no need to remember names or details. Just let yourself float through these spaces, imagining the soft glow of gas clouds around you, the gentle colors painting the darkness, the sense of space and peace that comes from being somewhere so vast and so quiet. Each nebula we visit will be a place to rest, a cosmic sanctuary where time moves slowly and where the concerns of daily life seem impossibly distant and small. Some of the nebulae we'll explore are among the most photographed objects in the universe, cosmic celebrities whose images have been captured by telescopes on Earth and in space. You might recognize some of them from pictures you've seen, but seeing them with your mind's eye as we float through them is different from seeing a photograph. In your imagination, you can experience them as three-dimensional places, clouds that surround you rather than flat images on a screen. You can sense their depth, imagine floating through layers of glowing gas. Picture yourself moving slowly through spaces so large that the human mind can barely grasp their scale. The gas that makes up nebulae is mostly hydrogen, the simplest and most common element in the universe, mixed with helium and trace amounts of other elements. This gas is spread incredibly thin, thousands or millions of times more diffuse than Earth's atmosphere, but there's so much of it, spread across such vast volumes, that it becomes visible, especially when it's energized by nearby stars or when it's dense enough to block background starlight. The dust mixed with the gas consists of tiny particles, microscopic grains of silicates and carbon compounds, each grain smaller than a particle of smoke, but collectively numbering in the trillions upon trillions, enough to give the nebula color and structure. These clouds don't just sit space. They're moving, flowing, responding to the gravity of nearby stars and the pressure of stellar winds and radiation. But their motion is imperceptibly slow from a human perspective. A nebula might be expanding or contracting, might be flowing past stars or being shaped by shock waves, but all of this happens so gradually that even if you watched for your entire lifetime, you wouldn't see any change. The nebula would look the same at the end of your life as it did at the beginning. This unchanging quality, this sense of eternal presence adds to their peaceful character. They're not static, but they're so slow-moving that they might as well be, creating an impression of permanence and stability. Imagine now that you're approaching your first nebula, still far away but close enough to see it as more than just a point of light. It spreads across your field of view, a cloud glowing softly in shades of red and pink, like a sunset that never ends, like a vast flower blooming in slow motion across light years of space. Stars are scattered through it, some in front, some behind, some embedded within the cloud itself, and their light illuminates the gas from within, making it glow. The nebula doesn't have sharp edges. It fades gradually into the darkness around it, its boundaries uncertain and undefined, blending into the background of space like watercolors blending on paper. As you drift closer, you begin to see structure within the cloud. There are denser regions and more diffuse regions, areas where the gas clumps together and areas where it's spread thin. There are streamers and filaments, flows and eddies, patterns created by the interaction between the gas and the light and wind from nearby stars. Some parts of the nebula are brighter than others, glowing more intensely where the gas is denser or where the illuminating stars are closer. The whole thing has a texture, a three-dimensional quality that no photograph can fully capture, a sense of depth and space that you can only appreciate when you imagine yourself actually there, floating within it. This is just the beginning of our journey, the first stop on our tour through the galaxy's most beautiful clouds. We'll spend time here, floating peacefully in the glow of this nebula, before moving on to visit others, each different, each beautiful, in its own way. There's no hurry, no pressure to move quickly. We're here to relax, to let go of stress and worry, to immerse ourselves in places so vast and so calm that they make our daily concerns seem insignificant. Let the gentle light of the nebula surround you. Let yourself float in this cosmic cloud, and feel your breathing slow and deepen as you drift through this peaceful place. The temperature here is cold, far colder than anything you've experienced on Earth, but you don't feel it. You're just observing, just floating, experiencing this place through your imagination rather than your physical senses. The cold is just another aspect of the nebula's character, a reminder that these are places far from any warming star, regions where matter exists in its most tenuous form, spread thin across vast distances, rarely there at all, yet somehow creating beauty on a cosmic scale. The cold preserves the nebula, keeps it from dispersing too quickly, allows it to exist for millions of years as a stable cloud before it's transformed by star formation or dispersed by stellar winds. Around you, the stars shine with steady light, unaffected by the nebula they're embedded in. The gas is too thin to obscure them significantly, too diffuse to scatter their light the way Earth's atmosphere does. They shine clearly, points of light scattered through the cloud like diamonds on velvet, each one a sun in its own right, each one potentially hosting planets and moons, and perhaps even life, though none of that matters right now. Right now, all that matters is the peace and beauty of this moment, floating in this cosmic cloud, surrounded by soft light and vast spaces, letting go of everything else and just being here in this imaginary place that's somehow more real and more meaningful than many actual places because of the peace it brings you. The nebula surrounding you now is what astronomers call an emission nebula, a cloud of gas that's glowing with its own light, energized by nearby stars. The process is simple and beautiful. Young, hot stars near the nebula emit intense ultraviolet radiation, light so energetic that it strips electrons from the hydrogen atoms in the gas cloud. When those electrons recombine with the hydrogen nuclei, they emit light at specific wavelengths, primarily a deep red color that gives many emission nebulae their characteristic crimson glow. This is the light you're seeing now, the gentle red luminescence that surrounds you, not reflected light like moonlight, but light created by the gas itself, a soft glow that seems to come from everywhere at once. Floating here in the heart of an emission nebula feels like being inside a living thing, something that breathes and glows with internal light. The color is not uniform but varies across the cloud, brighter where the gas is denser or where the energizing stars are closer, dimmer in regions further from the light source or where the gas is more diffuse. The overall effect is of being surrounded by a gentle red mist, a fog that extends in all directions as far as you can see, fading into darkness at the edges of your vision. It's warm in color but cold in temperature, a visual warmth that contradicts the actual frigid conditions of space, creating a comforting atmosphere despite the harsh reality of the environment. Some of the most famous nebulae in the universe are emission nebulae, glowing clouds that have captured human imagination since we first turned telescopes toward them. The Orion Nebula, perhaps the most photographed deep space object, is an emission nebula, a vast stellar nursery where new stars are being born, even as the gas around them glows with the energy of stars already formed. The Lagoon Nebula, the Rosette Nebula, the North American Nebula, all of these are emission nebulae, each glowing with that characteristic red light, each beautiful in its own unique way. But you're not looking at photographs now. You're here, or at least your imagination is here, floating within the cloud itself. The experience is completely different from seeing a picture. Pictures compress the nebula into a flat image, losing the sense of depth, the feeling of being surrounded by the glowing gas. Here, you can look in any direction and see the nebula around you, can imagine moving through it, and seeing how the view changes as you drift from one region to another. The nebula has depth and structure, layers of gas at different densities and temperatures, regions where new stars are forming, and regions where the gas is more stable and unchanging. The stars that energize this emission nebula are incredibly hot and bright, young, massive stars that burn fiercely but briefly, living fast and dying young in cosmic terms. These stars emit most of their light as ultraviolet radiation, invisible to human eyes but incredibly energetic, carrying enough energy to ionize the gas around them for light years in every direction. The zone around such a star where the gas is ionized and glowing is called an HI region, with the high denoting ionized hydrogen. These regions can be enormous, spanning dozens or even hundreds of light years, containing enough glowing gas to make thousands of stars if it were to collapse and condense. As you float through this glowing cloud, imagine the scale of what you're experiencing. That gentle red glow extends for light years in every direction. If you could see other travelers floating in this nebula with you, they might be trillions of kilometers away and still be within the same cloud, still surrounded by the same glowing gas. The nebula is so large that it takes light years to cross it, yet the gas is so thin that you could pass your hand through it and barely feel any resistance. It's almost nothing, yet it creates this vast, glowing presence, a cosmic cloud that's mostly empty space, but still manages to be one of the most beautiful things in the universe. The temperature of the gas in an emission nebula is actually quite high by everyday standards, often reaching 10,000 degrees or more, heated by the ultraviolet radiation from the nearby stars. But temperature in space doesn't mean the same thing it does on Earth. Temperature measures the average energy of individual particles, how fast they're moving, but in a gas this thin, there are so few particles that even though they're moving fast, they don't carry much total energy. You could pass through this hot gas and barely notice because there's simply not enough matter to transfer heat efficiently. It's hot, but not in a way that would burn you, energetic but diffuse, another paradox of these cosmic clouds. The red glow of hydrogen is not the only color present in emission nebulae. Other elements contribute their own colors when energized by stellar radiation. Oxygen emits greenish light, nitrogen adds hints of red and blue, sulfur contributes its own signature. When these colors are combined, emission nebulae can display a rich palette of hues, from deep crimson to soft pink, from cyan blue to golden yellow. Each color tells a story about the composition of the gas, about which elements are present, and in what quantities, about the history of the region, and what previous generations of stars have contributed to the cosmic mix. Imagine now that you're drifting toward a brighter region of the nebula, a place where the glow is more intense, where the gas is denser, and the illuminating stars are closer. The red light grows stronger. The mist around you becomes more visible, more substantial. You can see streamers and filaments of brighter gas cutting through the general glow, structures shaped by stellar winds and radiation pressure, by the motion of the gas and the influence of magnetic fields threading through the cloud. These structures add visual interest to the nebula, breaking up what might otherwise be a uniform glow into a complex tapestry of light and shadow. In some regions, you might see dark patches against the general red glow, shadows where denser knots of gas and dust block the light from behind, creating silhouettes against the bright background. These dark regions are not empty but rather so dense that they're opaque, concentrations of material that might be in the process of collapsing to form new stars, cosmic eggs waiting to hatch. They add contrast to the nebula, areas of darkness that make the glowing region seem even brighter by comparison, creating depth and dimension in the cloud. The stars embedded in the nebula shine with brilliant white or blue-white light. Their surface is so hot that they glow with a color that seems almost electric in its intensity. These are the young massive stars whose radiation energizes the gas around them, the powerhouses that make the nebula glow. Looking at one of these stars directly would be overwhelming even from a distance, their brightness and energy output far exceeding our sun's. But scattered through the nebula as they are, they become jewels set in a red mist, points of brilliant light that add to the beauty without overwhelming it. Some of these young stars are surrounded by their own smaller nebulae, cocoons of gas and dust that haven't yet been blown away by the star's radiation and stellar wind. These protoplanetary disks, as they're called, are where planets form, swirling clouds of material orbiting the young star, gradually clumping together to create worlds. You might be witnessing the birth of solar systems, watching places where planets are forming right now, where billions of years in the future, there might be worlds with oceans and mountains, perhaps even life. But all of that is potential, possibility, a future that hasn't happened yet. For now, there's only the disk and the young star and the glowing nebula surrounding it. As you continue to drift through this emission nebula, let yourself feel the peace of this place. Yes, there's energy here. The gas is ionized and glowing, stars are being born, but it's all happening so slowly from a human perspective that it might as well be static. The nebula will look essentially the same tomorrow as it does today, the same next year as this year, the same in 1,000 years as it does now. The changes that are occurring, the slow collapse of gas to form new stars, the gradual dispersal of the nebula by stellar winds, all of this happens on timescales of millions of years, far too slow for any human to perceive. What you experience is frozen beauty, a moment that extends across eons, peaceful in its slowness. Now let your journey take you to a different kind of nebula, one that doesn't glow with internal light, but instead reveals itself through absence, through what it hides rather than what it shows. You're approaching a dark nebula, a cloud of gas and dust so dense that it blocks the light from stars behind it, creating a shadow against the bright background of the Milky Way. From a distance, these dark nebulae look like holes in space, windows into nothingness. But as you draw closer, you realize they're not empty at all. They're full of material, thick clouds of dust and molecular gas, cold and dark and peaceful, in a completely different way than the glowing emission nebulae you just left. Entering a dark nebula is like moving from day into twilight. The stars that were bright and clear outside begin to dim as the dust absorbs and scatters their light. The darkness isn't complete. There's still a faint glow from light that is scattered through the cloud, but it's subtle, barely enough to see by, creating an atmosphere of deep shadow and mystery. This is not the darkness of empty space where there's nothing to see because there's nothing there. This is the darkness of concealment, of things hidden, of vast amounts of material spread through space, but material that doesn't shine, that keeps its secrets in shadow. The most famous dark nebulae have names that reflect their appearance. The Coalsack Nebula in the southern sky appears as a dark patch against the bright band of the Milky Way, looking exactly like a sack of coal spilled across the stars. The Horsehead Nebula, perhaps the most iconic dark nebula, rises like the silhouette of a horse's head against the glowing emission nebula behind it, a shape so perfect that it seems almost designed rather than accidental. Barnard's Dark Nebulae, a series of dark clouds catalogued by astronomer E. Barnard, create intricate patterns of shadow and light across the summer Milky Way, visible even to the naked eye from dark locations on Earth. But seeing these nebulae from Earth as dark patches against bright backgrounds doesn't prepare you for what it's like to be inside one. Here, surrounded by the dust and gas, the experience is one of muffled silence, of being wrapped in cosmic cotton, of existing in a place where light itself struggles to penetrate. The few photons that do make it through the cloud have been scattered many times, bounced from one dust grain to another, their journey randomized until they emerge traveling in new directions with their energy diminished. This creates the faint, diffuse glow that barely illuminates your surroundings, a twilight that extends in all directions without any obvious source. The dust grains that make up most of the opacity in a dark nebula are tiny, smaller than the particles in cigarette smoke, but there are so many of them, spread across light years of space, that collectively they block almost all the light trying to pass through. These grains are composed of silicates and carbon compounds, minerals and organics mixed together, each grain coated with a thin layer of ice, frozen water and other volatiles that have accumulated on its surface over millions of years. The grains are cold, just a few degrees above absolute zero, preserving the ice mantles that would vaporize instantly if exposed to starlight, but remain stable in the frigid depths of the dark nebula. Mixed with the dust is molecular gas, primarily molecular hydrogen, but also including carbon monoxide, ammonia, water, methanol, and dozens of other simple compounds. These molecules can only exist in the shaded environment of the dark nebula, protected from the harsh ultraviolet radiation that fills most of space and would tear them apart. In the darkness and cold, chemistry proceeds slowly, atoms meeting on the surfaces of dust grains and forming bonds, building up more complex molecules over millions of years. These dark nebulae are cosmic laboratories where the building blocks of life are created. where organic chemistry happens in space, where the materials that will someday be incorporated into planets and possibly into living things are slowly assembled. The temperature in a dark nebula is among the coldest in the universe, typically only 10 to 20 degrees above absolute zero. At these temperatures, most atoms and molecules have minimal thermal energy, moving sluggishly, barely vibrating. Time seems to slow down in the cold. Chemical reactions that might take seconds in warmer environments take thousands of years here. Everything proceeds at a glacial pace that makes the already slow processes of astronomy seem frantic by comparison. Yet this extreme cold is part of what makes dark nebulae so peaceful. There's no energy for violent processes, no heat to drive rapid change, just the slow, patient accumulation of material and the gradual, almost imperceptible evolution of the cloud. Floating through a dark nebula, you might feel a sense of isolation, of being cut off from the rest of the universe. The stars that provide orientation and reference in other parts of space are hidden here, blocked by the dust, leaving you surrounded by darkness with no obvious landmarks. It's easy to lose your sense of direction in such a place, to forget which way is up or down, which direction you came from or where you're going. But there's also peace in that disorientation, a sense of being completely present in the moment, because there's nothing to see except the immediate surroundings, no distant objects to pull your attention away, just the soft twilight and the sense of being wrapped in something vast and ancient. Some dark nebulae are so dense that they're completely opaque at visible wavelengths, blocking all the starlight trying to pass through them. These are called Bok globules, named after astronomer Bart Bok, who studied them extensively. They appear as pitch-black spheres or irregular shapes against brighter backgrounds, cosmic inkblots scattered across the sky. Inside one of these globules, the darkness would be absolute. No light penetrating from outside, the only illumination coming from the faint infrared glow of the dust itself, too dim for human eyes to see, but detectable by specialized instruments. It would be like being in a sensory deprivation chamber the size of a solar system, cut off from external stimuli, alone with your thoughts in the deepest darkness imaginable. Yet even in this darkness there's activity, though you'd never know it by looking. Deep within the densest parts of dark nebulae, gravity is slowly winning its eternal battle against pressure. The cloud is contracting imperceptibly slowly, pulling itself together under its own weight. Over millions of years, this contraction will cause the central regions to become denser and warmer, eventually triggering the collapse that will form new stars. But that's still far in the future. For now, the cloud is stable, balanced between the inward pull of gravity and the outward push of internal pressure, existing in a state of peaceful equilibrium that could last for millions of years more before the balance tips and star formation begins. The boundaries of dark nebulae are not sharp, but gradual, the darkness fading slowly into the star-filled space beyond as the dust thins out. Moving through this transition zone, you'd see more and more stars appearing as the obscuration decreases, the darkness giving way to twilight, then to the normal appearance of space with stars scattered everywhere. It's a gentle transition, a slow emergence from shadow into light, and you can pause here at the edge, halfway between darkness and brightness, appreciating both the mystery of the dark cloud you're leaving and the beauty of the star field you're entering. Dark nebulae teach us that not everything beautiful needs to glow or shine. Sometimes beauty is found in shadows, and the spaces between light and the gentle darkness that provides contrast to make brightness meaningful. These clouds are beautiful precisely because they don't emit light, because they create shapes and patterns through absence rather than presence, because they show us that the universe has quiet, hidden places that keep their secrets in shadow. As you drift away from the dark nebula, heading toward your next destination, you carry with you the peace of that darkness, the calm that comes from being in a place where light itself rests, where the usual brightness of space gives way to gentle shadow. Your journey continues now to yet another type of cosmic cloud, one that neither glows with its own light like an emission nebula, nor blocks light like a dark nebula, but instead reveals itself through reflected starlight. You're approaching a reflection nebula, a cloud of dust that scatters the light from nearby stars, creating a soft, diffuse glow in shades of blue and white, like moonlight on mist, like streetlights in fog, but on a cosmic scale. These nebulae are gentler than emission nebulae, their light softer and more subtle, creating an atmosphere of calm and quiet beauty. The blue color of reflection nebulae comes from the same physics that makes Earth's sky blue. The dust particles in the cloud are just the right size to scatter blue light more efficiently than red light. So when white starlight hits the cloud, the blue wavelengths are scattered in all directions, while the red wavelengths pass through with less scattering. The result is that the nebula appears blue when viewed from most angles, a soft azure glow that seems to float in space, neither as dramatic as the reds of emission nebulae, nor as mysterious as the darkness of dark nebulae, but beautiful in a quieter, more understated way. One of the most famous reflection nebulae surrounds the Pleiades star cluster, also known as the Seven Sisters. These young blue stars are embedded in a faint cloud of dust left over from their formation, and this dust scatters the star's light, creating a soft blue glow around the cluster. From Earth, even modest telescopes can see hints of this nebulosity. Wisps of light around the brightest stars, and photographs reveal the full extent of the cloud, like silk scarves draped around jewels. Here, floating near the Pleiades, you can appreciate this beauty directly, seeing how the starlight illuminates the dust, creating layers of increasing brightness near each star, fading gradually into darkness with distance. The stars that illuminate reflection nebulae are typically not as hot or as energetic as those that create emission nebulae. They're often young stars, blue or white in color, but not the extremely massive ultra-hot stars that produce the intense ultraviolet radiation needed to ionize gas. Their light is strong enough to be scattered by dust, but not energetic enough to make gas glow. This creates a different relationship between star and nebula, less violent, more gentle, like moonlight compared to sunlight. The nebula doesn't blaze with light, but rather glows softly, illuminated but not overwhelmed by its stellar companions. Floating through a reflection nebula feels like moving through illuminated mist, the kind you might see on Earth when car headlights shine through fog, creating visible beams and halos. But here the mist extends for light years. The illumination comes from stars instead of headlights, and the effect is visible because you're in space where there's no atmosphere to further scatter the light. The dust around you catches and redirects the starlight, making the normally invisible dust clouds visible, revealing structure and flow in what would otherwise be empty-looking space. It's a reminder that space is not truly empty, but contains tenuous material that usually goes unseen. The dust and reflection nebulae is similar to that in dark nebulae, tiny grains of silicates and carbon compounds, each coated with ice. But here the dust is illuminated rather than shadowed, revealed rather than hidden. The grains are still incredibly small and incredibly far apart, but there are enough of them distributed across such vast volumes that their collective effect is visible as the soft glow you see around you. Each grain is scattering photons, sending them off in random directions, and some of those photons reach your eyes, allowing you to perceive the cloud that would otherwise be invisible. Reflection nebulae often exist near dark nebulae, sometimes as the illuminated edges of larger dark clouds. A single cloud complex might have dark regions in its interior where no stars are present to illuminate the dust. Emission regions near hot young stars that ionize the gas, and reflection regions near cooler stars that merely illuminate without ionizing. As you move through such a complex, you'd see the character of the nebula change, the glow shifting from blue reflected light to red emission to darkness, and back again, each region blending into the next, creating a rich tapestry of light and shadow, color and darkness. The brightness of a reflection nebula depends on several factors: the brightness of the illuminating star, the distance between star and cloud, and the density and composition of the dust. Near a bright star, the nebula might shine strongly, clearly visible even from great distances. Further from the star, or in regions where the dust is less dense, the glow fades, becoming more subtle, requiring darker skies and more sensitive eyes or instruments to detect. This creates a gradient of brightness, the nebula brightest near its stars and fading gradually with distance, like the glow around a candle fading into darkness. Imagine drifting through layers of this blue glow, moving from dimmer outer regions toward brighter areas near the stars. The light around you strengthens gradually. The mist becomes more visible, more substantial seeming, even though its actual density barely changes. You can see streamers and wisps in the cloud, structures created by the motion of gas and dust, by the pressure of starlight and stellar winds, by magnetic fields and turbulence. These structures catch the light differently, creating brighter filaments and darker lanes, adding texture and depth to what might otherwise be a uniform glow. Near the illuminating stars, the reflection nebula might be bright enough to cast visible shadows, regions where denser concentrations of dust block some of the scattered light, creating darker areas against the brighter background. These shadows add drama to the scene, breaking up the uniform glow, creating contrast that helps your eye perceive depth and structure. You might see pillars or columns of dust rising from darker regions, their edges illuminated by scattered starlight, creating shapes that remind you of terrestrial landscapes, even though they exist on scales millions of times larger. The peace of a reflection nebula comes partly from its soft light, the gentle blue glow that's easy on the eyes, non-threatening, calming in its subtlety. There's no harsh glare here, no overwhelming brightness, just a diffuse luminescence that reveals without dazzling, that shows without blinding. It's the kind of light you might want in a bedroom, soft and dim enough to allow sleep, but present enough to provide comfort, to keep complete darkness at bay. Here in space, it creates an environment that feels safe and welcoming, a place where you could rest and relax, where the gentle light watches over you like a nightlight. Reflection nebulae also remind us that light is not just something that exists at its source, and at its destination, but something that fills the space between, something that can be seen in transit if there's matter present to reveal it. The light from these stars has been traveling through space, invisible and unnoticed, until it encounters the dust of the nebula and is scattered, made visible by its interaction with matter. This makes the invisible visible, reveals the hidden light that fills all of space, shows us that even in the darkness between stars, starlight is present, just waiting for something to scatter it and make it known. As you prepare to move on from this reflection nebula, to continue your journey through the cosmos, take a moment to appreciate the quiet beauty of this place. Let the soft blue light surround you. Let yourself feel the peace that comes from being in a space that's illuminated but not bright, visible but not garish, present but not demanding. This is the beauty of reflected light, of seeing something not by its own glow, but by the light it borrows from others. And there's a lesson in that about how beauty can come from reflecting the light around us, from showing what's there rather than generating our own glare. Your journey now takes you toward one of the most beautiful and poignant types of nebulae in the universe, the planetary nebulae. Despite their name, these clouds have nothing to do with planets. They were named centuries ago by astronomers who, looking through primitive telescopes, thought they resembled the pale disks of distant planets. But we know now that there's something very different, something both sadder and more beautiful. A planetary nebula is the outer layers of a dying star cast off into space when the star exhausted its fuel and could no longer hold itself together. What you're approaching now is the cosmic equivalent of a sunset, the final chapter in a star's life, rendered in glowing gas and intricate shapes. These nebulae are smaller than the vast star-forming regions you visited, typically only a light year or two across rather than dozens or hundreds, but they're often more clearly defined with sharp edges and geometric shapes that seem almost artificial in their regularity. Some are spherical, perfect bubbles of gas expanding into space. Others are bipolar, with lobes extending in opposite directions like cosmic butterflies or hourglasses. Still others have complex, nested shells or intricate filaments, each one unique, each one a work of cosmic art, created in the final gasps of a dying star. At the center of each planetary nebula sits the remnant of the star that created it, a white dwarf, the exposed core of what was once a sun like ours, or perhaps a bit larger. This tiny stellar remnant is incredibly hot, its surface temperature reaching 100,000 degrees or more, and it bathes the surrounding nebula in intense ultraviolet radiation. This radiation ionizes the gas in the nebula, making it glow with the same emission mechanism you saw earlier. But here the effect is concentrated in a smaller volume, creating brighter, more vivid colors and more defined structures than in the sprawling emission nebulae of star-forming regions. Imagine approaching one of these planetary nebulae now, perhaps the Ring Nebula in Lyra or the Cat's Eye Nebula in Draco, famous examples that have been photographed countless times. From a distance, it appears as a perfect ring or oval of glowing gas, green and blue and red, surrounding a tiny, bright point at the center. As you draw closer, you begin to see details, structure within the ring, variations in brightness and color, hints of three-dimensional form that photographs flatten into 2 dimensions. The ring is actually a cylinder or barrel of gas, and you're looking at it from the side, seeing both the near and far walls superimposed, which creates the ring-like appearance. Moving closer still, you can appreciate the shell structure of the nebula. The gas isn't distributed uniformly, but in layers, shells within shells, each one representing a different episode in the star's death throes, each one expanding at a slightly different speed, creating concentric rings like tree rings recording the star's history. The innermost shells are moving fastest, pushed by the intense radiation and wind from the central star, while the outer shells, expelled earlier, move more slowly, having had more time to decelerate as they plow through the thin interstellar medium. The colors in planetary nebulae are among the most vivid in astronomy, not the subtle blues of reflection nebulae or the soft reds of emission nebulae, but intense, almost neon-bright hues that seem too saturated to be natural. Green light comes from doubly ionized oxygen, a bright jade color that dominates many planetary nebulae. Red comes from hydrogen and nitrogen, blue from helium and oxygen, creating a palette that would look artificial if you didn't know it was produced by simple atomic physics, electrons falling from higher to lower energy levels and emitting specific wavelengths of light in the process. Floating through a planetary nebula is a very different experience from drifting through a star-forming region. The space feels more confined, more intimate. You're not in a vast cloud stretching light years in every direction, but in a relatively small bubble, small enough that you can see across it, see the far side of the nebula from the near side. Appreciate it as a complete object rather than an endless expanse. The central star is clearly visible, a bright white point blazing with energy, the heart of the nebula, the reason for its existence. Everything else flows from that central point, the expanding shells of gas, the radiation that makes them glow, the wind that shapes them. Some planetary nebulae have shapes that seem impossibly regular and symmetrical, like geometric figures drawn with cosmic compasses. The Helix Nebula looks like a giant eye staring out of space, its inner ring perfectly circular, surrounded by a fainter outer halo. The Eskimo Nebula has a face-like appearance with a circular inner region and filaments extending outward like a parka's fur-lined hood. The Butterfly Nebula shows perfect bilateral symmetry, with two lobes extending in opposite directions, mirror images of each other, suggesting that some process during the star's death created a preferred axis and expelled material along it. These shapes tell stories about the dying stars that created them. A spherical nebula suggests a star that died alone, expanding its outer layers uniformly in all directions. A bipolar nebula suggests a star that was rotating rapidly or had a companion star or planet that created an equatorial disk, channeling the dying star's wind into two jets perpendicular to that disk. The more complex shapes with multiple lobes and filaments and knots of denser gas suggest even more complicated histories, perhaps multiple episodes of mass loss or interactions with the surrounding interstellar medium that sculpted the expanding gas into intricate forms. The gas in planetary nebulae is expanding, moving outward from the central star at speeds of tens of kilometers per second. This expansion is visible in photographs taken years apart, the nebula growing perceptibly larger as its shells spread into space. But from your perspective, floating here in the present moment, the motion is imperceptible. The nebula appears frozen, static, unchanging during the time you spend observing it. Only sensitive instruments measuring the Doppler shifts of the gas could reveal the expansion, the motion hidden beneath the apparent stillness. another reminder that things in space that seem permanent are actually transient, that even these beautiful nebulae are temporary phenomena that will fade and disperse in tens of thousands of years. The peace in a planetary nebula comes partly from its completeness, its wholeness. This is not a nebula in the process of becoming something else, not a cloud waiting to form stars or a remnant waiting to cool. This is a finished work, the final artistic statement of a dying star, complete and perfect in this moment, even though it will eventually fade. There's peace in endings as well as beginnings, in the completion of a cycle, in the knowledge that this star lived its life, burned its fuel, and created something beautiful in its passing. The nebula is a monument to that star's existence, a memorial that will persist for thousands of years after the star itself has faded to a cold, dark ember. Looking at the central white dwarf, you're seeing the future of our own sun, the fate that awaits it billions of years from now when it exhausts its hydrogen and helium fuel. That tiny star, so small that it's barely larger than Earth, but so dense that a teaspoon of its matter would weigh tons, is all that remains of what was once a normal star, perhaps much like the sun we orbit. Everything else, the star's outer layers, the enormous volume of gas that made up most of its mass, all of that has been expelled into space, creating the nebula you see around you. The white dwarf will continue to cool for trillions of years, slowly fading, while the nebula disperses, its gas mixing with the interstellar medium, contributing to future generations of stars and planets. This cycle of stellar death and rebirth is fundamental to the universe's evolution. The gas expelled by dying stars is enriched with heavier elements, carbon and nitrogen and oxygen, elements that didn't exist when the universe began, but were created through fusion in stellar cores. These elements are essential for life as we know it. The carbon in our bodies, the oxygen we breathe, the nitrogen in our DNA, all of it was created in stars and distributed through space by processes like the one that created this planetary nebula. Looking at this glowing cloud, you're seeing not just beauty, but cosmic recycling in action, matter being returned to space to be used again, the universe constantly transforming itself, creating new from old. As you drift through this planetary nebula, let yourself appreciate both its beauty and its meaning, the visual splendor and the cosmic significance. This is a place of transformation, where endings become beginnings, where a star's death creates the seeds of future life, where loss becomes legacy. The peace here is the peace of acceptance, of natural processes completing their cycles, of beauty arising from change and transformation. Let the glow of the nebula surround you, let its colors wash over you, and feel the calm that comes from witnessing something that's both ending and eternal, temporary in form but permanent in impact. Your journey continues now to places born from violence but evolved into peace, the supernova remnants scattered through the galaxy. These are the expanding shells of gas ejected when massive stars died in catastrophic explosions, events so energetic that for a few weeks a single supernova can outshine an entire galaxy. But those explosions happened centuries or millennia or tens of thousands of years ago, and what remains now is not violence but something approaching tranquility, expanding bubbles of gas that have slowed and cooled, decorated with filaments and shock waves, but no longer dangerous, no longer destroying, instead creating beauty from destruction, peace from chaos. Approaching a supernova remnant is like approaching the scene of an ancient disaster long after the event, when nature has begun to reclaim the space. when the raw destruction has been softened by time. The most famous supernova remnant is the Crab Nebula, the remains of a star that exploded in the year 1054, an event recorded by Chinese and Arab astronomers who saw a new star appear in the sky, bright enough to be visible during the day for weeks. That explosion happened nearly 1,000 years ago by Earth's calendar, and the debris has been expanding ever since, creating a tangled web of filaments glowing in reds and blues, powered by a pulsar at the center, the collapsed core of the exploded star. The Crab Nebula is unusual because it's still energetic, still being powered by its central pulsar, which spins 30 times per second and floods the nebula with relativistic particles and electromagnetic radiation. But many supernova remnants are quieter, having long since exhausted their initial energy and settled into a more peaceful expansion. The Veil Nebula is such a remnant, the debris from a supernova that exploded perhaps 8,000 years ago, now forming a delicate lacework of filaments spanning several degrees of sky, glowing softly as the expanding shock wave compresses and heats the interstellar medium it plows through. Imagine yourself floating near the Veil Nebula now, approaching one of its long, graceful filaments. The structure is impossibly thin and delicate, like cosmic lace, like gossamer threads drawn across space. The filament is actually a shock front, a place where the expanding supernova debris is colliding with the surrounding interstellar gas, compressing and heating it to temperatures of millions of degrees. But the density is so low that even at these extreme temperatures, the gas doesn't carry much energy. What you see is not a threatening wall of fire, but a beautiful luminous curtain glowing with the characteristic colors of shocked gas, reds from hydrogen, blues from oxygen. The colors in supernova remnants can be even more complex than in other nebulae, because the physics involves not just ionization by ultraviolet light, but also collisional excitation by shock waves. Different elements emit different colors when shocked, creating a rich palette. Sulfur adds deep reds, oxygen creates blues and greens, hydrogen contributes its usual red, and all of these colors can be present in different parts of the remnant, painting the expanding bubble with multiple hues. In false color images that assign different wavelengths to different colors, supernova remnants become psychedelic artworks, abstract expressionist paintings rendered in glowing gas. The structure of supernova remnants evolves over time. Young remnants like Cassiopeia A are compact and bright, their debris still relatively concentrated, their expansion still rapid. Middle-aged remnants like the Veil Nebula have spread out, their filaments separated by large voids, their expansion slowed by interaction with the interstellar medium. Old remnants become so diffuse and faint that they're difficult to detect, merged back into the general interstellar medium, their identity as separate objects fading as they age. This evolution from youth to old age mirrors stellar evolution, another cycle of birth, life, and dissolution that plays out across cosmic timescales. Floating through a supernova remnant, you'd be surrounded by these glowing filaments, thin sheets and strands of gas creating a three-dimensional network of light against the darkness. The space between filaments is not empty, but filled with much fainter, more diffuse emission, the general glow of heated gas that doesn't show up well in photographs, but would be visible to your dark adapted eyes. The overall impression would be of being inside a structure, a framework of light defining a volume that extends for dozens of light years in every direction, a bubble or shell that's hollow in the middle, where the supernova cleared out the surrounding space. The center of some supernova remnants contains the collapsed remnant of the star that exploded, either a neutron star or, in the most massive cases, a black hole. These objects are fascinating but not peaceful, the neutron stars often spinning rapidly and emitting beams of radiation, the black holes consuming any matter that strays too close. But you're not visiting the center now. You're exploring the outer shell, the expanding debris, the parts of the supernova remnant that have left behind their violent origins and become something more serene, more contemplative, more suited to a journey seeking peace and beauty. The filaments in supernova remnants often show intricate structure at every scale, large-scale patterns of expansion and interaction, medium-scale knots and twists where the shock wave has encountered denser regions of interstellar gas, and fine-scale ripples and variations that hint at turbulence and magnetic field structure. This multi-scale complexity means that no matter how close you get or how far away you move, there's always more detail to see, always new structure revealing itself. It's fractal-like in its endless complexity, beautiful at every level of magnification, never becoming simple or boring no matter how much you observe. Some supernova remnants are associated with historical supernova, explosions that were bright enough to be seen from Earth and recorded in historical documents. The Crab Nebula from 1054, Tycho's supernova from 1572, Kepler's supernova from 1604. Each of these events was witnessed by human observers and recorded in astronomical logs or historical chronicles. Looking at the remnants now, expanding and fading but still visible, creates a connection across centuries, a reminder that humans have been watching the sky and noting changes for as long as we've been capable of recording our observations. These remnants are historical documents as well as astronomical objects, physical records of specific events that people witnessed and wondered about. But most supernova remnants in the galaxy are not associated with historical observations, simply because they exploded too long ago or too far away, or were obscured by interstellar dust. These anonymous remnants are no less beautiful or significant, just less connected to human history. They expanded and evolved without anyone watching, creating their beauty in isolation, without observers to appreciate or record it. There's something appropriate about that, the idea that beauty exists whether or not anyone sees it, that the universe creates art for its own sake rather than for an audience, that these glowing shells would be here and be beautiful even if intelligent life had never evolved anywhere to appreciate them. The expansion of supernova remnants will continue for hundreds of thousands of years, the shells growing larger and fainter as they spread their energy over increasing volumes. Eventually, they'll merge back into the interstellar medium completely, becoming indistinguishable from the general background, their identity as separate objects lost. But they'll leave their mark on the galaxy, having enriched the interstellar medium with heavy elements created in the supernova explosion, having stirred up the gas and perhaps triggered new star formation through their passage, having contributed to the cosmic cycle of stellar birth and death that has been ongoing since the first generation of stars formed billions of years ago. As you drift through this supernova remnant, let yourself appreciate the transformation from violence to peace, from destruction to beauty. The explosion that created this nebula was one of the most energetic events in the universe. briefly generating more power than entire galaxies. But that was long ago. What remains is gentle, beautiful, peaceful, the embers of cosmic fire cooled to a warm glow. There's a lesson here about time and healing, about how even the most violent events eventually give way to calm, how destruction can ultimately lead to creation, how chaos can evolve into order and beauty. Let the soft glow of the filaments surround you and feel the peace that comes from witnessing transformation complete. Now let's move away from contemplating specific nebulae and instead focus on what it would truly feel like to exist within one, to be immersed in these cosmic clouds, to experience them not as distant objects to observe, but as environments to inhabit, at least in imagination. Close your eyes and picture yourself floating, weightless and peaceful, suspended in a vast ocean of glowing gas and dust, surrounded in all directions by soft light and color. No solid ground beneath you, no ceiling above you, just infinite space filled with luminous mist. The first thing you'd notice about being inside a nebula is the sense of scale, or rather the loss of any intuitive sense of scale. On Earth, we judge distances by familiar objects, knowing roughly how far away something is because we know how big it should be. But in a nebula, there are no familiar objects. The gas extends in every direction as far as you can see, and there's no way to tell if what you're looking at is a small feature close by or an enormous feature far away. A bright knot of gas might be the size of our solar system but a light year away, or it might be only a few astronomical units across but much closer. Without depth cues, everything flattens into a dreamlike landscape where distance becomes meaningless. This disorientation might be unsettling at first, but let it become soothing instead. Without the normal cues that orient us in space, you're free to simply exist, to float without worrying about direction or destination, to let go of the need to know where you are or where you're going. The nebula surrounds you like a warm bath, supporting you, holding you gently in its tenuous embrace. There's no gravity to pull you down, no forces acting on you except perhaps the faint radiation pressure from distant stars, barely enough to notice, certainly not enough to disturb your peaceful floating. The light within a nebula comes from everywhere and nowhere, diffuse and directionless, creating an environment with soft shadows, or sometimes no shadows at all. If you held up your hand, you might see it outlined against a brighter background, but it wouldn't cast a sharp shadow the way it would in sunlight, because the light isn't coming from a single direction, but from all around you, scattered and re-scattered by dust until it fills the space uniformly. This shadowless light is dreamlike, unreal, the kind of illumination you might imagine in a dream where things are visible, but you can't quite identify the light source. The colors surrounding you would depend on what type of nebula you're in: the deep reds of an emission nebula, the soft blues of a reflection nebula, the multiple hues of a planetary nebula or supernova remnant. But whatever the colors, they would be gentle, not harsh or glaring, creating an atmosphere more like candlelight than sunlight, intimate rather than overwhelming. These are colors to relax by, to let wash over you, to breathe in as if color were something you could inhale, letting it fill your lungs and your body and your mind with its particular energy and mood. Imagine moving through the nebula now, not with any particular destination, but just drifting, letting yourself be carried by whatever gentle currents might exist in the gas, though in reality the gas is so thin that you'd barely feel any resistance to your motion. You pass through regions of varying brightness, areas where the gas glows more intensely and areas where it's dimmer, transitions that happen gradually, blending from one state to another without sharp boundaries. The nebula reveals itself slowly, new features coming into view as you approach them, old features fading into the background as you move away, creating a constantly shifting but never jarring visual experience. Sometimes you might see stars through the nebula, points of brilliant white or blue light shining through the mist like lanterns in fog. These stars anchor the scene, providing reference points in the otherwise undifferentiated cloud, reminding you that you're in a real place, not just floating in abstract colored light. Some stars might be closer than others, appearing brighter and larger, while distant ones are reduced to faint glimmers, barely visible through the intervening gas. The combination of nebula and stars creates depth, layers of light at different distances, helping your mind construct a three-dimensional understanding of the space you're in. The temperature in most nebulae is cold, far below zero, but in this imaginary journey, you don't feel the cold. You're somehow protected, able to exist comfortably in this environment that would be instantly lethal to an unprotected human body. This is a dream journey, after all, an exploration of imagination rather than physical reality, and in dreams we can float through space without freezing, can breathe without air, can experience beauty without dying in the attempt. Let yourself embrace the unreality of it, the impossibility of it, because that impossibility is what makes it peaceful, freeing you from the constraints and dangers of reality. As you float deeper into the nebula, you might notice structure in the gas, currents and flows, regions where the density varies. These aren't clouds in the sense of discrete objects, but variations in an otherwise continuous medium, like currents in water or regions of different temperature in air. The gas might be flowing past you, though you can't feel it because it's so thin, moving in patterns determined by turbulence, by magnetic fields, by the pressure of radiation from nearby stars. These flows create the filaments and streams you see, organize the chaos into patterns, turn random motions into something that looks purposeful, even though it's purely physical. The sound in a nebula would be silence, absolute and complete, because sound requires matter to travel through, and while nebulae contain matter, it's far too diffuse to carry sound waves. Even if you could make a noise, clapping your hands or shouting, the sound wouldn't travel more than a few meters before dying out, absorbed by the vacuum without creating echoes or reflections. This silence is profound, deeper than any quiet you can experience on Earth, where even in the most isolated places there's always some ambient sound, wind or birds, or the ringing in your own ears. In the nebula, there would be nothing, just visual beauty and absolute quiet, a combination that invites meditation and rest. Imagine finding a particularly beautiful region of the nebula and stopping there, ceasing your motion and simply floating in place, letting yourself become part of the scene rather than a visitor passing through. The gas glows around you, stars shine in the distance, and you're suspended in this moment, this place, perfectly still and perfectly content. There's nowhere else you need to be, nothing else you need to do. No obligations or concerns beyond simply being here, experiencing this beauty, letting it fill your consciousness until there's no room for worry or stress or the countless small anxieties of daily life. This is what it means to be inside a nebula, to be immersed in cosmic beauty, to float in a place where the normal rules don't apply, and where peace comes not from the absence of stimulation, but from stimulation, so gentle and so beautiful that it calms rather than excites, soothes rather than disturbs. Let yourself stay here as long as you like, floating in your chosen spot, surrounded by glowing gas and distant stars, experiencing a peace that's both profound and simple, available to anyone who can close their eyes and imagine themselves in these cosmic clouds. When you're ready to move on, you can drift toward a new region, explore a different part of the nebula, or move toward another nebula entirely. But there's no rush, no pressure to keep moving. The nebulae aren't going anywhere. They'll be here whenever you want to return, waiting patiently in their slow-motion evolution, creating beauty whether anyone observes it or not, existing in their own time, their own space, their own perfect peace. For now, just float and breathe, and let the nebula hold you. Let its colors and light fill your vision, and feel yourself becoming calmer, more relaxed, more ready for the sleep that's approaching. Your peaceful journey through the nebulae now brings you to regions where creation is happening, where the tranquil clouds you've been floating through are beginning to stir with new activity. These are stellar nurseries, places where gravity is slowly winning its eternal battle with pressure, where gas clouds are collapsing to form new stars, where the cycle of stellar birth continues as it has for billions of years. But even here, in these sites of creation, there's peace to be found, because stellar birth is not sudden or violent, but slow and gradual, a process that unfolds over millions of years, gentle in its inexorability. You're approaching now one of the great stellar nurseries of our galaxy, perhaps the Eagle Nebula with its famous pillars of creation, or the Orion Nebula where thousands of stars are being born simultaneously, or the Carina Nebula with its massive stars and towering clouds. From a distance, the nursery appears as a complex region of light and shadow, bright areas where young stars have already formed and are illuminating their surroundings, darker areas where clouds of dust block the light, and intermediate zones where star formation is in progress, hidden from visible light but detectable in infrared. The pillars and columns that characterize many stellar nurseries are among the most iconic structures in astronomy, towers of gas and dust that rise from darker clouds, their surfaces illuminated by nearby stars while their interiors remain dark and cold. These pillars are sites of ongoing star formation, with dense cores at their tips where new stars are condensing from the surrounding gas. The pillars themselves are being eroded by the intense radiation from massive stars elsewhere in the nursery, their surfaces being photoevaporated, stripped away layer by layer. But this process is slow enough that the pillars persist for tens of thousands of years, appearing essentially frozen in time to human observers. Imagine floating toward one of these pillars now, approaching a structure several light years tall, dwarfing our entire solar system. The pillar rises from a darker cloud below, its surface glowing softly with scattered and reflected starlight, its interior hidden in shadow. At the tip of the pillar, barely visible even in infrared, are small dark knots, evaporating gaseous globules or EGGs, cocoons of dense gas where protostars are forming, future suns that will someday shine on their own, but that for now are hidden, gestating in darkness, not yet ready to emerge. The process of star formation begins when a region of a molecular cloud becomes dense enough that its own gravity overcomes the outward pressure of the gas. This can happen spontaneously in very large clouds, or it can be triggered by external events like the shock wave from a nearby supernova or the compression caused by a passing spiral density wave in the galaxy. Once collapse begins, it's inexorable, gravity pulling the gas inward, increasing the density, which increases the gravitational pull, creating a runaway process that will continue until either a star forms or the cloud fragments into smaller pieces that each form their own stars. But this collapse is slow by human standards, taking hundreds of thousands or millions of years from the initial contraction to the moment when fusion ignites and a true star is born. During all this time, the forming star is hidden within its cocoon of gas and dust, invisible at optical wavelengths but glowing in infrared as gravitational contraction heats the gas. These protostars are like cosmic embryos, developing in the darkness of their dusty wombs, going through stages of growth and evolution before they emerge as fully formed stars, ready to take their places in the galactic community. As you drift through this stellar nursery, you can see signs of different stages of star formation happening simultaneously. Some regions contain the very youngest protostars, barely visible even in infrared, still deeply embedded in their natal clouds. Other regions contain more evolved protostars that have cleared some of the surrounding gas and are beginning to be visible at shorter wavelengths, though still shrouded in dust. And in the brightest, most active regions, you see newly formed stars that have finally achieved fusion and are blazing with their own light, illuminating the gas around them, creating the emission nebulae that make stellar nurseries so beautiful. These newly formed stars are often surrounded by circumstellar disks, flattened clouds of gas and dust orbiting the young star, material left over from the star's formation that hasn't yet fallen onto the star or been blown away by stellar winds. These disks are where planets form, where the dust grains collide and stick together, gradually building up larger and larger objects, from pebbles to boulders to planetesimals to protoplanets to full-sized worlds. Looking at these disks, you're witnessing the birthplaces of planetary systems, seeing the raw materials from which worlds will someday form, perhaps including worlds that will eventually harbor life. The most massive stars and stellar nurseries are incredibly bright and hot, emitting vast amounts of ultraviolet radiation that ionizes the surrounding gas and creates the bright emission nebulae that dominate many nurseries. These massive stars burn ferociously but briefly, living only a few million years before exhausting their fuel and exploding as supernova. They're the rock stars of stellar nurseries, bright and attention-grabbing, but they represent a small minority of the stars being formed. Most of the stars forming in these clouds are smaller, dimmer, longer-lived stars like our Sun, or even smaller red dwarfs that will burn for trillions of years, outliving not just the massive stars, but potentially outliving the universe's current era. The interplay between star formation and the surrounding nebula is complex and dynamic. Young stars don't just passively form from the cloud, they affect the cloud in turn, their radiation and stellar winds heating, ionizing, and eventually dispersing the gas around them. This creates a self-regulating system where star formation eventually destroys the very clouds that gave birth to the stars, limiting how many stars can form before the nursery is disrupted. The most massive stars are particularly effective at this. Their intense radiation and powerful winds creating bubbles of hot gas that sweep up the surrounding material, sometimes triggering new star formation at the edges of the bubble while suppressing it in the interior. Floating through a stellar nursery, you'd see this interplay in action. bright regions where young stars have already formed and are illuminating their surroundings, dark pillars and globules where star formation is still ongoing, and ragged edges where the gas is being torn apart by stellar winds and radiation. The environment is more dynamic than in the nebulae you visited before, with more variation, more contrast, more sense of ongoing activity. Yet it's still peaceful because the timescales are so long, the changes so gradual, that watching for a human lifetime would reveal almost no change, the scene appearing essentially frozen despite the activity occurring within it. The colors in stellar nurseries can be particularly rich, combining the reds of hydrogen emission with the blues and greens of other elements, the dark silhouettes of dust clouds, the bright whites and blues of hot young stars, and sometimes the orange and red glows of reflection nebulae where cooler stars illuminate surrounding dust. This creates a complex palette, layers of different colors at different depths, giving the nursery a three-dimensional quality that's more pronounced than in simpler nebulae. Your eye doesn't know where to settle, drawn from one beautiful feature to another, each one worthy of attention, each one contributing to the overall scene. Some stellar nurseries are close enough to Earth that they're visible to the naked eye, fuzzy patches in the sky that resolve into intricate cloudscapes in photographs. The Orion Nebula is perhaps the best example, visible as the middle star in Orion's sword, though it's not actually a star but a glowing cloud of gas about 1,300 light-years away. In dark skies with good conditions, even binoculars reveal its nebulous nature, and telescopes show increasing detail. The central cluster of young stars, called the trapezium, the glowing gas illuminated by those stars, and hints of the larger molecular cloud complex that surrounds the visible nebula. But most stellar nurseries are hidden from casual observation, obscured by dust or too far away to be easily visible. The galaxy is full of them, hundreds or thousands of regions where stars are forming right now, each one contributing its quota of new stars to the galactic population. Most of these nurseries will never be famous, will never have their portraits taken by space telescopes, will form their stars and disperse and be forgotten without ever being noticed by humans. Yet they're no less important, no less beautiful, no less fundamental to the galaxy's evolution than the famous nurseries we know by name. As you prepare to leave this stellar nursery to continue your journey toward sleep and rest, take a moment to appreciate what you've witnessed. You've seen creation in progress, watched as new stars form from ancient clouds, observed the cycle of stellar birth that has been ongoing since the first generation of stars formed in the early universe. These newborn stars will live their lives, some briefly, some for trillions of years, contributing their light and energy to the galaxy, perhaps hosting planets and life before eventually dying and returning their matter to space to be recycled into future generations. The cycle continues, endless and eternal, and you've had the privilege of witnessing one small part of it, floating peacefully through a cosmic nursery where the universe creates its own future. Now let's take a final tour through some of the most famous and beloved nebulae in our galaxy, visiting cosmic landmarks that have inspired astronomers and artists for generations. Each of these nebulae has its own character, its own personality, its own particular beauty, and visiting them in imagination is like touring the great museums of the world, seeing masterpieces you've heard about, encountering beauty that's both familiar from photographs and new in your direct experience. Let yourself drift from one to another, spending time with each, appreciating what makes it special and unique. First, let's visit the Orion Nebula, perhaps the most famous nebula in the sky, visible even to the naked eye as a fuzzy patch in the Sword of Orion. This is one of the closest stellar nurseries to Earth, only about 1,300 light-years away, close enough that we can see extraordinary detail, individual stars forming, protoplanetary disks around young stars, structures, and flows in the gas. Floating here, you're surrounded by glowing red and pink gas, illuminated by the 4 massive stars of the trapezium at the nebula's heart. These young stars, only a few million years old, pour out intense ultraviolet radiation that makes the entire nebula glow, creating one of the brightest emission nebulae in our sky. The Orion Nebula is actually just a small part of a much larger cloud complex, the Orion Molecular Cloud, which extends across much of the constellation. The visible nebula is like a blister on the surface of this cloud, a region where hot young stars have blown away enough dust that we can see into the interior, while most of the cloud remains dark and hidden. Floating in the visible nebula, you can see the darker regions surrounding you, clouds that block the background starlight, hinting at the vast reservoir of gas that will form future generations of stars over the next several million years. Next, let's travel to the Horsehead Nebula, one of the most iconic dark nebulae, a pillar of dust rising from a larger cloud, its shape resembling a horse's head in perfect silhouette against the brighter emission nebula behind it. This is a small nebula, only about 3 light-years tall, but its distinctive shape has made it one of the most photographed objects in the sky. Floating near the Horsehead, you can appreciate its 3-dimensional structure, seeing how it's actually a pillar extending toward you from the cloud behind. Its horsehead shape created by our particular viewing angle, probably looking quite different from other directions. The Horsehead Nebula is part of the same cloud complex that contains the Orion Nebula, lying about 1,500 light-years from Earth, and the bright emission nebula behind it, IC 434, is illuminated by the hot star Sigma Orionis. The contrast between the dark silhouette and the bright background creates a dramatic image, but being here, you can see that the Horsehead itself is not completely dark. There's a faint glow from its surface, where radiation from nearby stars is slowly eroding it, photo-evaporating the outer layers, revealing the denser interior. Eventually, perhaps in a few million years, the Horsehead will be completely eroded away, another temporary sculpture in the galaxy's ongoing art exhibition. Now let's drift to the Ring Nebula, one of the brightest and most easily observed planetary nebulae, visible even in small telescopes as a perfect ring or oval of glowing gas. We visited planetary nebulae earlier, but the Ring Nebula deserves special mention as perhaps the most observed planetary nebula in the sky, a favorite target for amateur astronomers because it's bright, easy to find, and shows clear structure even in modest instruments. Floating here, you can see that the ring is actually a cylinder or barrel of gas viewed from the side, the near and far walls superimposed to create the ring appearance, while the thinner gas in the middle and at the ends is too faint to see clearly. The central star of the Ring Nebula is a hot white dwarf, the exposed core of what was once a star somewhat more massive than our Sun. This star's temperature exceeds 100,000 degrees, and it bathes the nebula in intense ultraviolet radiation, making the gas glow with vivid colors: blue from helium and oxygen, green from doubly ionized oxygen, red from hydrogen and nitrogen. The nebula is expanding at about 20 kilometers per second, growing larger with each passing year, though this expansion is imperceptible without precise measurements across decades. The Ring Nebula is about 2,000 light-years from Earth and about 1 light-year in diameter, making it relatively small and compact compared to emission nebulae, but large enough to show beautiful detail. Let's visit now the Eagle Nebula, home to the famous pillars of creation photographed by the Hubble Space Telescope, perhaps the most iconic astronomical image ever taken. These pillars are towers of gas and dust several light-years tall, their surfaces glowing softly with light from nearby hot stars while their interiors remain dark and cold, protecting the protostars forming within from the harsh radiation outside. The tallest pillar stretches about 4 light-years, nearly the distance from our Sun to the nearest star, and at its tip are small, dense knots where new stars are gestating, hidden in darkness until they're ready to emerge. Floating among the pillars of creation, you're surrounded by structures on a scale that defies comprehension. Towers that dwarf anything on Earth or in our solar system, cosmic monuments that have existed for tens of thousands of years and will persist for thousands more before they're completely eroded by stellar radiation. The pillars are being sculpted by the intense ultraviolet light from massive stars elsewhere in the Eagle Nebula, their surfaces being evaporated at rates of about 1 Earth mass of material per year, which sounds like a lot but is tiny compared to the total mass of the pillars. They're slowly being destroyed, but so slowly that they appear permanent, frozen sculptures that define this region of space. Next, let's journey to the Lagoon Nebula, a vast stellar nursery about 4,000 light-years from Earth, one of only 2 star-forming nebulae visible to the naked eye from mid-northern latitudes. The lagoon spans about 100 light-years, making it much larger than the Orion Nebula, and contains numerous young stars, including several very massive ones that flood the region with ultraviolet radiation. The nebula gets its name from the dark lane of dust that seems to divide it into 2 sections, creating a lagoon-like appearance in photographs. Floating here, you can see that this dark lane is actually a thick band of dust seen edge-on, a sheet that cuts through the nebula and blocks the light from gas behind it. The Lagoon Nebula contains several distinct features, including a bright knot called the Hourglass Nebula, where especially intense star formation is occurring, and numerous dark globules where future stars are condensing. The colors are rich and varied. Deep reds from hydrogen emission dominate, but there are patches of blue where starlight reflects off dust, and regions of orange and yellow where different elements contribute their signatures. The overall scene is one of incredible complexity and activity. Thousands of stars at different stages of formation, clouds in various states of illumination and erosion, a cosmic ecosystem where birth and change are ongoing. Let's visit the Carina Nebula now, one of the largest and brightest nebulae in the southern sky, about 7,500 light-years from Earth and spanning over 300 light-years. This is a region of massive star formation containing some of the most luminous stars known, including Eta Carinae, a star so massive and unstable that it could explode as a supernova at any time. The Carina Nebula is spectacular in photographs, showing intricate structures, bright emission regions, dark dust lanes, and countless young stars, creating a scene of almost overwhelming complexity and beauty. Floating through the Carina Nebula, you're surrounded by towers and pillars similar to those in the Eagle Nebula, but on even grander scales. Structures tens of light years tall, shaped by the radiation and winds from the region's massive stars. Some of these pillars are being destroyed rapidly, their surfaces evaporating so quickly that measurable changes occur over just a few decades, giving astronomers the rare opportunity to watch nebula structure evolving in something approaching real time. The colors are vivid, the reds especially intense, and the contrast between bright and dark regions creates dramatic visual effects, landscapes that look almost geological despite existing in the vacuum of space. Finally, let's visit the Helix Nebula, the nearest planetary nebula to Earth, at only about 700 light-years away, appearing as a large ring or eye shape in the sky. The Helix is one of the most extensively studied planetary nebulae because its proximity allows us to see extraordinary detail, including thousands of small knots and filaments in the outer regions, each one potentially harboring material equivalent to several times the mass of Earth. Floating here, you can appreciate the Helix's three-dimensional structure, seeing that it's actually two rings or cylinders nested at angles to each other, creating its complex appearance. The central star of the Helix is a white dwarf, cooling slowly toward its final dark state, its surface temperature still around 120,000 degrees, but gradually declining. The nebula itself is expanding at about 30 kilometers per second, growing larger each year, currently spanning about 3 light years in diameter. The colors are subtle but beautiful. Blues and greens from oxygen dominate the inner regions, while reds from hydrogen and nitrogen color the outer zones, creating a gradient that adds depth and dimension to the scene. The Helix has been called the Eye of God because of its appearance, a cosmic eye staring out of space. But floating within it, you experience it not as an eye but as a vast, peaceful space filled with glowing gas, a cathedral of light created by a dying star. These famous nebulae are just a few of the thousands that populate our galaxy, each one unique, each one beautiful in its own way, each one a reminder of the incredible variety and splendor that the universe creates through simple physical processes acting over cosmic timescales. As you prepare to complete your journey and drift toward sleep, let these images fill your mind. These places you visited in imagination, these cosmic clouds that exist in reality millions of trillions of kilometers away, but that you've experienced tonight as intimate, peaceful spaces where beauty and tranquility reign. Your journey through the nebulae is drawing to a close now, but the peace and beauty you've experienced will stay with you as you drift towards sleep. You've traveled through glowing emission nebulae and dark clouds, visited reflection nebulae and planetary nebulae, explored supernova remnants and stellar nurseries, floated through famous cosmic landmarks, and imagined yourself immersed in these vast, gentle spaces. Each nebula offered its own form of peace, its own particular beauty, its own invitation to relax and let go of the concerns of daily life. Now, as you prepare to sleep, let all these experiences blend together into a general sense of calm and wonder. Imagine yourself floating one last time in a nebula of your own choosing, perhaps returning to your favorite from tonight's journey or creating a composite of all the nebulae you've visited, a personal cosmic cloud that combines the best features of each. The light around you is soft and gentle, neither too bright nor too dim, creating perfect conditions for rest. The colors are soothing, blues and reds and greens blending harmoniously, none of them jarring or demanding, all of them contributing to an atmosphere of peace and tranquility. Stars shine through the mist, distant and steady, anchoring the scene without dominating it. You're floating in perfect comfort, weightless and supported, with no strain on your body, no tension in your muscles, no discomfort of any kind. The nebula holds you gently, like floating in warm water, like resting on the most comfortable bed imaginable, like being cradled in a cosmic embrace that asks nothing of you except to relax and be present. Your breathing has become slow and deep, each breath effortless, each exhalation releasing more tension, more worry, more of whatever thoughts or concerns you carried with you into this journey. The scale of the nebula around you is both vast and intimate, extending for light years in every direction, yet feeling like a personal space, a sanctuary created just for you, a place where you can rest without interruption or disturbance. The silence is complete, not empty or lonely, but full and peaceful, the kind of silence that allows you to hear your own thoughts clearly if you choose to think, or to let your mind become quiet if you prefer, simply existing without the constant chatter of mental activity. This is a silence that heals, that restores, that reminds you what peace feels like when you're not fighting it or questioning it, but simply accepting it. As you float here, you might notice that the boundaries between yourself and the nebula are becoming less distinct. You're not separate from this cosmic cloud, but part of it. Your atoms once were stardust and will return to stardust. Your matter is temporarily organized into a human form, but is fundamentally the same stuff that makes up these glowing gases, these dust clouds, these stars. There's no real separation between you and the universe, only a temporary arrangement. And recognizing this can bring a profound sense of peace, a feeling of belonging to something larger than yourself, something ancient and eternal. The nebula is teaching you its greatest lesson now, the lesson of existing without striving, of being without needing to become something else. These cosmic clouds don't struggle or worry about their purpose or future. They simply are, existing in their current state, beautiful and complete regardless of whether anyone observes them or appreciates them. They don't need validation or meaning from external sources. Their existence is sufficient justification for their existence. And you, floating here, can experience that same simplicity, that same acceptance, letting go of the need to justify or explain or improve yourself, just being, just existing, just resting in the present moment. Your body is becoming heavier now, or perhaps lighter. It's hard to tell which, because the distinction between heavy and light is losing meaning. You're sinking into comfort, settling into rest, your mind following your body into deeper relaxation. The nebula continues to glow softly around you, unchanging and eternal, a constant presence that will be here whether you're awake or asleep, whether you're thinking about it or not. This knowledge is comforting, the idea that these beautiful places exist independently of your awareness, that the universe continues to create and maintain its beauty regardless of observers, that peace and splendor are fundamental properties of reality rather than rare and fleeting conditions. As sleep approaches, the nebula might seem to fade slightly, the colors becoming softer, the light dimmer, though whether this is the nebula changing or your perception changing is impossible to say and doesn't really matter. What matters is the feeling of peace that's settled over you, the deep relaxation that's permeated your body and mind, the sense that you've been on a journey to beautiful places, And now you're returning to rest, carrying those memories and feelings with you into sleep. The nebula has given you its gift of peace, and you're accepting that gift gratefully, letting it ease you into dreams. The stars visible through the nebula might seem to pulse gently now, growing slightly brighter and dimmer in rhythm with your breathing. Or perhaps your breathing is synchronizing with their pulse, a cosmic rhythm that connects you to something larger than yourself. Each breath in draws peace and calm from the nebula. Each breath out releases tension and worry into the cosmic void, where it disperses harmlessly, unable to disturb the vast tranquility that surrounds you. This breathing could continue forever, this peaceful exchange between you and the universe, this simple rhythm that sustains life and promotes rest. The nebula might begin to move now, or you might be moving through it, a gentle drift that requires no effort on your part, carrying you deeper into its heart, deeper into peace, deeper into rest. The boundaries of the nebula are expanding, or you're shrinking, or perhaps the distinction between inside and outside is dissolving, leaving you neither in the nebula nor separate from it, but somehow existing as part of it, one small piece of the cosmic whole, conscious but not separate, aware but not isolated. This feeling is profoundly peaceful, this recognition of connection, this experience of unity. As you drift deeper into sleep, the nebula continues its patient existence, glowing softly in space, unconcerned with time or change, eternal in its slow evolution, beautiful in its simplicity. It doesn't need you to observe it to exist, doesn't require your appreciation to be beautiful, doesn't depend on your consciousness to be real. But it has been here for you tonight, providing a sanctuary for your imagination, a peaceful space for your mind to explore while your body rests. And it will be here tomorrow night if you wish to return, always present, always peaceful, always ready to receive you and hold you gently while you rest. The cosmic clouds are calling you to sleep now, their soft glow fading as your eyes close, their colors blending into the darkness behind your eyelids, their peace settling into your heart like dust settling after a storm. You've traveled far tonight, explored vast reaches of space, witnessed beauty on scales that dwarf human comprehension, and now you're ready to rest, to let go completely, to surrender to sleep and to dreams. The nebulae will continue their slow dance through the galaxy, without you, patient and eternal. And when you wake, they'll still be there, waiting for your return, ready to offer their peace again. Let yourself sink now into deep sleep, floating in your nebula, surrounded by soft light and gentle colors, supported by the cosmic embrace of these ancient clouds. Your journey is complete, your exploration finished for tonight, and all that remains is rest. The universe holds you safely, the nebulae cradle you gently, and sleep welcomes you home. Let go of everything now, all thoughts, all concerns, all awareness, and drift into dreams as peaceful and beautiful as the cosmic clouds you've been exploring. The nebulae bid you good night, their light a benediction, their peace a gift, and you accept both gratefully as you surrender to sleep. And now the space sounds continue, deep and resonant, a cosmic lullaby, vibrations from the depths of space converted to sound for your comfort and peace. Let them carry you now, carry you fully into sleep, into the peaceful darkness where consciousness fades and dreams may bloom or silence may reign. Either way is perfect. Either way is rest. Either way serves its purpose, renewing body and mind, preparing you for another day of existence Another day of experiencing this remarkable universe, another day of being conscious matter in an ancient cosmos. Good night. Rest well. The nebulae glow on in peaceful silence. The stars shine in patient constancy. And you sleep held by existence itself, safe in the cosmos, part of the grand eternal story. Sleep now. Just sleep. The journey through nebulae is complete. The contemplation is finished. Now comes rest, simple, uncomplicated, beautiful rest. Sleep.